Welcome back to the Solutions Manual. In this video, we will solve the problem 2.11 from Alexander and Sadiku Fundamentals of Electric Circuits 5th edition. According to this problem, in the circuit of figure 2.75, in this figure, we have to calculate V1 and V2. So to solve this problem, we will use the Kirchhoff's voltage law, also known as KVL in short. But before that, we have to consider a sign convention that we will use in this problem. So this sign convention is for cells or batteries. So number one, if the direction of loop, I believe that you are familiar with this term loop. Loop is the any closed path in a circuit. So if the direction of loop is from the positive to the negative terminal, then we would consider the potential difference across that cell or battery as negative. But if the direction of loop is from the negative to the positive terminal of the cell, then we would consider the potential difference as positive across that cell. So this is the sign convention that we will use. So this is my loop 1 and this is my loop 2. I have considered the direction of both of the loops as clockwise, but if you want to, you can consider their directions as counterclockwise. They would still give you the same answer. So starting with loop 1. So for loop 1, so applying the KVL, that is algebraic sum of potential differences in a closed loop is 0. Now I want you to analyze the movement of the loop L1. The loop L1 is moving in the clockwise direction, and when it is passing through the V1, it is moving from the negative to the positive terminal. So according to the sign convention, if the direction of loop is from the negative to the positive terminal, the potential difference will be taken as positive. So V1 will be taken as positive. The direction of the loop across 1 volt is from the positive to the negative terminal. The potential difference according to the sign convention will be taken as negative. So negative 1. Now here, since the loop is moving in the clockwise direction, the direction of the loop is from the positive to the negative terminal across 5 volts. So the potential difference of 5 volts will be taken as negative. So negative 5 equals to 0. So from here, V1 comes out to be 6 volts. So this is our first answer. Now for loop 2. Again we have to apply the KVL. So algebraic sum of potential differences in a closed loop is 0. Now I want you to analyze the movement of the loop L2. So loop L2 is moving in the clockwise direction. So when it moves from this 5 volts, it is moving from negative to the positive terminal. So according to the sign convention, these 5 volts will be taken as positive. Now across this 2 volts, the direction of the loop is from the positive to the negative terminal. So these 2 volts will be taken as negative. And across this V2, the direction of the loop is from the positive to the negative terminal. So V2 will also be taken as negative, equals to 0. So from here, V2 comes out to be 3 volts. So this is our second answer. So this is it for this problem. I hope you would find this video helpful. If you do, please make sure to subscribe to this channel and also turn on the bell icon for the daily updates. And if you have any questions or any doubts in the KVL or in the KCL, then feel free to ask in the comment section and I will try to answer them as soon as possible. Thank you.